The truth they desperately tried to bury is simple. We could have been on Mars in 10 days. But the solution was so absolutely insane, the world collectively said, nah, we're good. Asterisk, asterisk, we're talking about a forgotten project where the key to unlocking the entire solar system was hiding in the darkest corner of science. This is the story of how some of the smartest people in the world, the same folks who built the atomic bomb, decided the future of space travel lay in writing a never-ending series of nuclear explosions. This isn't science fiction. It's the chaotic, asterisk exposed asterisk truth they wanted to bury. But first, to understand the sheer genius and the sheer madness, we need to talk about the real villain of the space race number one. The rocket equation or I.P. The main problem isn't gravity. It's math. It's the asterisk rocket equation. It demands that if you want to go fast, you need more fuel. And if you need more fuel, your rocket needs to be bigger. And if it's bigger, you need more fuel to lift the fuel. And suddenly you're left with a massive, ridiculous stack of expensive trash that you just jettison into the ocean. Asterisk, asterisk, visual cue. Show a massive Saturn V next to a tiny toy rocket. Text, more fuel equals more problems. Use the distracted boyfriend meme if possible. Boyfriend looks at nuke. Ignoring the chemical rocket, asterisk the Manhattan Project scientists saw this bloated problem and, naturally, had a nuclear solution. They weren't thinking about boring, slow nuclear reactors that give off thermal power. That's like trying to drain a swimming pool with a straw inefficient and useless for massive thrust. They looked at the atom bomb and saw something else. Raw, instant, unhinged power. One little nuclear bomb delivered the punch of asterisk tens of thousands of tons asterisk of chemical fuel. If you could somehow harness that explosion, you wouldn't just be going to space. You'd be breaking space. The only way to move a vehicle using nuclear blasts, however, was to strap it directly inside the fireball of an atom bomb. Most rational people today would immediately hit the asterisk facepalm asterisk button and say, yeah, that's called self-destruction. Genius. But this was the 50s. OSHA didn't even exist. And these guys, bless their chaotic hearts, had a different approach. This is how the legend of asterisk Project Orion asterisk was born. ###. 2. The secret ingredient, graphite and Lou Allen's Balst. First question they had to answer was the most important. Asterisk, what exactly can survive a nuclear blast? Asterisk, surprisingly, the US military was very interested in this, but for shelter and warhead spacing. They were eagerly testing everything, literally placing materials at ground zero. And these tests led to the first asterisk shocking asterisk discovery. Enter the glorious, scientifically named asterisk Lou Allen's balls. Asterisk Lou Allen was testing whether lithium could be converted to tritium inside a blast. So they took meter-wide steel spheres, filled them with lithium material, and placed them just 10 meters from a 20-kiloton blast. The spheres were coated in asterisk graphite, a material chosen because it needs huge amounts of energy to vaporize. The results were the stuff of scientific legend. When the balls were engulfed in a asterisk 150,000 degree fireball asterisk, that's not a typo, folks. A millimeter-thick layer of graphite instantly vaporized, creating a protective gas shield. The spheres survived without a scratch. Asterisk, but the second discovery. That was the key. Asterisk, the expansion of that gas shield shot the spheres out of the fireball like cannonballs. The power of a nuclear bomb harnessed for propulsion. The idea was ignored until Sputnik sailed over America in 1957, kicking off the space race. Suddenly, vast resources were unlocked for any technology, no matter how bad SHT crazy. Project Orion officially began. They weren't just sketching ideas. They were testing designs, including a small rocket that was pushed 100 meters high by 6 conventional explosive blasts. The dream was simple. Asterisk Alpha Centauri in a human lifetime. Asterisk ###. 3. The unhinged engineering, pusher plate, and the airbase. Focus landed on the 4,000-ton Orion ship, a 78-meter-tall bullet that could deliver 1,115 tons into orbit, or a whopping 300 tons to Mars and back without refueling. This was a massive step ahead capable of carrying entire space stations in one piece. So, how did they protect the squishy humans inside from an endless assault of atomic bombs? Through for critical and frankly terrifying elements. Element 2, the suspension system. Facing the nuclear blasts was a massive 26-meter steel disc called the pusher plate, coated in oil to act as a sacrificial layer. The tungsten gases from the nukes would slam into this plate, transferring momentum. The plate, however, would be violently slammed backward with forces in the thousands of Gs enough to turn a human into chunky salsa. The first fix? A giant gas bag, like an airbag from a car crash. That would reduce the acceleration from thousands of Gs to a mere few hundred Gs, still enough to crush a human instantly. The final layer of protection was the 27-meter-long suspension arm, a huge system of springs and hydraulic pistons that delayed and smoothed the pushes into an average shove of 1.5 grams. The engineers optimistically claimed it would be about as bumpy as driving down a country road. Visual cue. Show a calm person driving a beat-up truck on a dirt road, immediately followed by the confused math lady. Meme trying to reconcile 1.5 grams with thousands of Gs being absorbed. 4. The weaponized engine, 100 terawatts of tnth. Most important component was the nuclear devices themselves. They couldn't be huge. They had to be small, powerful, and efficient, a concept the U.S. military conveniently perfected for their new line of submarine-launched ballistic missiles. The key was plutonium and beryllium casing to efficiently recycle neutrons. This approach was perfectly suited for Orion, leading to the creation of pulse units. These were miniaturized nukes, about a ton each, releasing the energy equivalent of 25,000 tons of TNT*. The tungsten plate was the true genius. In space, an atom bomb is just a flashbulb and a wave of radiation useless for moving things. The thick tungsten plate intercepts the deadly X-rays and plasma, absorbing the energy and then exploding outward as a rush of hypervelocity gas. That is the rocket exhaust. They were detonated roughly once per second, releasing an average of 100 terawatts of instantaneous power. That is 5 times more power than all of humanity uses today. Orion had an exhaust velocity 10 times better than any chemical rocket. It was an engineering spectacle. Number 5. NASA's nightmare and the doomsday Orion. This marvel of nuclear chaos wasn't killed by a design flaw, it was killed by bureaucracy. When NASA took over Project Orion in 1958, they took less than a year to realize they absolutely did not want to deal with the secrecy and headaches of handling thousands of nuclear explosives. Not only that, NASA was busy pouring billions into the Saturn family of rockets to land on the moon, a task that one 4,000-ton Orion launch could match in total lift capacity. Orion was going to make their multi-billion-dollar investment obsolete overnight. Visual cue. Distracted boyfriend meme. Boyfriend is the DOD military. Girlfriend is the Saturn V. Woman walking by is the Orion ship. So, they quietly shopped Orion to the Department of Defense DOD. Needless to say, the DOD loved the idea of a vehicle capable of lifting an entire battleship full of ballistic missiles into space. This led to some truly insane creations. There was the Asterisk Emergency Command and Control Orion, sitting in a silo like an ICBM, ready to launch only during a nuclear war to become a flying NO or AD backup. But the most unhinged was the Asterisk Doomsday Orion. This thing was designed to place a ** 1,650-ton thermonuclear weapon * in low Earth orbit with a yield matching all of the combined American warheads. It could set a land area larger than France on fire just by detonating in space. President Kennedy reportedly rejected a military version as horrifying and unnecessary. Good call, Mr. President. Number 6. The political and explosive Phalith military loved the concept. But the project had an unavoidable problem. The public. A ground-launched Orion, taking off over major cities with hundreds of nukes. Politically, that was a gigantic ** nope. Engineers were forced to design smaller vehicles that had to be chemically boosted to a 76-kilometer altitude before starting the nuclear phase, hoping the fallout would just disperse harmlessly. A full safety study detailed the grim reality: high-altitude EMPs that would knock out nearby satellites, misfires, and the terrifying worst-case scenario, a failure during the climb, scattering radioactive material over ** thousands of kilometers *. What finally killed the dream of writing nuclear blasts wasn't engineering failure. It was * diplomacy. The 1960 Cuban Missile Crisis led to the * 1963 Partial Nuclear Test Ban Treaty *, which outlawed detonating nuclear bombs at high altitudes or in space. Since the Orion pulse units looked exactly like bombs and an Orion launch would trigger attack alarm systems globally, the project was finally untenable. Orion died in 1965. ###7. The Resurrection, Mars in 10 days again. The dream never fully faded. Orion veterans kept the concept alive, even showing it off during the early development of 2001, A Space Odyssey. Decades of research have offered to key modern solutions to the insanity. First, * microfission. Forget using huge, compressed plutonium cores. Microfission uses tiny fuel pellets less than 100 grams magnetically compressed by an external electric field. This is * much smaller than any original Orion pulse unit. Second, the * magnetic nozzle. This genius concept can catch and redirect the superheated plasma vapor because the pulses are so much weaker. You don't need the crazy gas bag or the 27-meter suspension arm. The magnetic nozzle can even extract energy from the plasma to ***, recharge the capacitors * for the next pulse. The result: the modern * mini-mag * concept would have an exhaust velocity * 40 times better * than any chemical rocket, achieve a comfortable 1 gram of acceleration, and reach a velocity that could get you to * Mars in 10 days * or Jupiter and back in under a year. ###. Conclusion: the Cosmic Chicken and Egg Mini Mag fixes all the safety issues. It only works in a vacuum, uses tiny fuel pellets, and is dramatically safer. So why aren't we doing this? We're stuck in a * Cosmic Chicken and Egg * problem. Orion is a high-performance system that needs massive funding. It would only get that funding if NASA or DOE had an intensive, high-speed mission that required it. But no one is seriously talking about sending astronauts to Jupiter or Mars in 10 days because * current technology can't do it. * the technology can't get funding without the mission. And the mission doesn't exist without the technology, but history has a twisted sense of humor. Competition, perhaps from China, or technological leaps in unrelated fields like magnetic fusion research, might force the US to dust off the plans for the nuclear rocket. Nuclear pulse propulsion remains a massive leap forward. waiting for the one event that might force the world to ride a controlled series of atomic explosions into the great beyond. Asterisk, what do asterisk you think is the one crazy, impossible mission that would finally make NASA say, DMN it, let's go nuclear? Let the Jester know in the comments. Asterisk, asterisk.